Hello and welcome to the next lecture in the structural design and drawing 3. So in previous lecture we have started the unit number 5, that is liquid retaining structures. So before starting the lecture, again I want to acknowledge these textbook, reference book and the IS code referred for the preparation of these lecture series and the uh, course material for the structural design and drawing 3. So we have started in the previous lecture with the syllabus content of the liquid retaining structures. So this is the syllabus content and the different code required for the same. Mainly that is 3370 part 1, 2, 3 and 4 required for the design purpose or study purpose of the liquid retaining structures or the water tank resting on the ground. Also we have studied the need of this liquid retaining structure or the water tank. Then the types of water tank based on the different condition. Then through the flow chart we have seen the types of the water tank based on the placement of the tank and based on the shape of the tank. So these are some pictures or photographs that shows the different types of water tanks used. Also we have seen the comparison of the water tank or say silent features of each type of water tank. Then we have seen the classification based on the design of the water tank. First, that is based on the shape, cylindrical, rectangular. Second, based on the position, that is nothing but underground or resting on the ground or elevated service reservoir. And all these are again designed based on the type of joint between the wall and the base slab, that is flexible or free, hinge and fixed type of joint. Also we have seen some requirement from the water tank based on the type of tank or where should be feasibility of each tank. Then how the analysis can be done, the behavior of the wall, then the joints, how to detail the joints of the water tank, that is also we have seen in the previous lecture. For flexible, then hinge base, and for fixed base the detailing also we have seen. Then the behavior of the flexible base and the rigid base tank, okay, after the hydrostatic force when the act from the water, that also we have seen here in this diagram. Then the hook tension and the bending moment behavior of that cylindrical wall, especially it is shown in these figures. For the hook tension, this is the behavior of the tank wall, and for the different base condition, or that for different boundary condition, that is joint between the wall and the base slab. Similarly, the vertical bending moment variation in the wall, it is also shown here. So this is the flexible base joint, that detailing is also shown here. This is the enlarged view of the same. So then general requirements also we have seen. So minimum cement should be less than or should not be less than 305 kg per meter cube, while the maximal cement content should not be exceed 450 kg per meter cube as per the code. And the minimum grade of the concrete that is to be used for the liquid retaining structure or the water tank should not be less than M25 grade. So also whatever to avoid the leakage problem, limit state method of the design should be avoided so as to get uncracked section. Okay, and as per the IS 456, the permissible within whatever the stress is generated, those should be within the permissible limit in case of the direct tension or tension bending out. And for that purpose we have to specially refer the IS 3370 as we have discussed, or the guidelines given in the IS 3370 as earlier we have discussed. So some crack development pattern, or we can say that the points we have discussed, and for that the remedy also we have discussed in the previous lecture. Now the podal provision also, that is yes, as per the working stress design methods, we have to make the code provision or different codes clauses we have seen. As per 4.5.1 design basis, it is given in this clause over the page number 2 of IS 3370 part 2. So this is nothing but table number 1, permissible concrete stress in the calculation relating to the resistance to the cracking. Okay, that is given in again IS 3370. Then again, for the calculation of the stresses for the flexure as well as the direct tension, or that is combination of the two relating to the resistance to the cracking, how it is to be calculated, that is also given in this clause. That is nothing but no crackings in the strength calculation has no tensile strength that is to be considered. Then permissible stress in concrete for resisting the cracking, that is as per the clause number 4.5.2.1 that we have to take into consideration. And for the strength calculation 4.5.2.2, these two clauses we have to refer, and based on that clause 4.5.2.2, a table is given that gives the permissible stresses in concrete in Newton per mm square. Okay, for a different grade of concrete it is mentioned from M25 to M50 for the value that is in direct tension due to the bending, and permissible stress in the bond, that is average for the plain bars, it is given in this table. Again, the permissible stress in concrete for the working stress method is given in table number 3, okay, of IS 3370 part 2, page number 3. Also this table is available in IS 456 for the working stress method. So again, these are nothing but some notes that we have to check or also incorporate or change or modify the value of the bond strength according to the zone in which the reinforcement bar is located or type of the bar. Then permissible stresses in steel, especially in resistance to cracking, that we have to check 4.5.3. Again, strength calculation as per the permissible stresses in steel reinforcement for the strength calculation, that is given by the code for the again types of stress in the steel reinforcement, that may be tensile or compressive stress. Based on that, these value for the plain mild steel bars and the high strength reform bar or TMT bars, these value we have to consider for tensile as well as compressive stresses. Then the next clause that is today we are going to see, that is nothing but clause number 5 for the floor in case of the water tank, and this clause this is included in the IS 3370 part 2 and over page number 4. Okay, so this clause says, clause number 5.1, provision of the moment joint. So moment joint shall be provided in accordance with this IS 3370 part 1. So 5.2, floor of the tanks resting on the ground. It is mentioned here, the floor of the tanks resting on the ground shall be accordance with this IS 3310 or 3370 part 1. So again 5.3, that it shows a floor to tank resting floor of the wall tank resting on the support, that is ground support most of the time. If the tank is supported on the wall or either on other side of support, the floor slab shall be designed for the bending moment. Means on all four sides. For example, this is a circular tank and it is only supported over its periphery or perimeter. Then here it is the slab of the tank, and this should be designed for the bending, okay, due to the water load and also the self weight of the slab. The worst condition of the loading may not be those given in this IS code clause 22.4.1 of, that is IS 456, since water level exceeds or extends over all the spans in normal construction except in case of the multi-cell tanks. These will have to determine by designer. Okay, it's special clause, we can say that here. This we have to determine, okay, in each particular case or different case. So when it is also the 5.3.1 says that when the floor is rigidly connected to the wall, okay, as it is generally in case, the bending moments at the junction between the wall and the floor shall be taken into account in the design of the floor together with any direct forces transferred to the floor from the wall. Means we have to consider the bending moment effect, okay, along with the whatever the different forces, direct or indirect, coming over the from the wall on the floor or from the floor to the wall due to the suspension of the floor from the wall. Then clause number 6, that is based related to the walls of the liquid retaining structure or the water tank. IS 3370 again part 2, page number 4, in that it is given this clause 6.1 for provision of the joints. In that again 6.1.1, so this is for the sliding joint at the base of the wall. So it is desired to allow, okay, when it is desired to allow the walls to expand or contract separately from the floor, or to prevent the moment at the base, means zero moment to the wall, that is owing to the fixity to the floor, sliding joints may be employed. So 6.1.1.1, that construction affecting the spacing of the vertical movement joints are discussed in the IS 3370. Part 1. While the majority of these joints may be the partial or complete contraction type of joint, sufficient joints of the expansion type should be provided to satisfy the requirements of this IS. Here it is again IS 3370, printing mistake or typing mistake. So again, as per the clause 6.2, how the pressure of the water that should be considered on the wall, and this is located or given on the page number 4 of IS 3370 part 2. So it says that the IS 6.2.1 in liquid retaining structures with the fixed or the floating covers, the gas pressure developed above the liquid surface shall be added to the liquid pressure. That is depend on the type of content or the whatever the storage of the tank. Then second, that is IS clause number 6.2.2, when the wall of a retaining wall structure is built in ground or has earth embankment against it, the effect of earth pressure shall be taken into account as the discussed in this IS 3370 part 1. Then clause number 6.3, wall of the tank, that is rectangular or the polygonal in plan. So while designing the wall of the rectangular or the polygonal concrete tanks, the different points that we have to take into care, that is nothing but first, that is in the plane walls, the liquid pressure is registered by the both vertical as well as the horizontal bending moment, and estimate of the bending moment in the vertical and the horizontal plane should be made. The horizontal tension caused by the direct pull due to the water pressure on the end wall should be added to that resulting from the horizontal bending moment. Okay, so these are all clause, that is I am just reading. Okay, so if you are having any doubt, you can ask in between or in the discussion session. Okay, So I am just getting you the familiar with the clause number, that is important from the whatever the basic knowledge point of view of design of the liquid retaining structure or the water tank. Okay, it is very important. Then third point in clause number 6.3 on liquid retaining faces. Okay, the tensile stress due to the combined or the direct horizontal tension and the bending action shall satisfy the different conditions, that those are nothing but, so this is main condition it should satisfied for this one, that is on liquid retaining phase the tensile stress due to the combined direct, that is combined means axial and the tension, axial and bending stress and the tensile stress or tension load, that should satisfy this condition, that is sigma ct dash plus sigma ct plus sigma cbt dash divided by sigma cbt should be less than or equal to 1, where this sigma ct dash is calculated, or it is equal to, the meaning of this term is calculated direct tensile stress in the concrete. Then sigma ct, that is nothing but permissible direct tensile stress in the concrete, that is we have to consider, or you have to take that value from the table number 1 that we have earlier seen. And sigma cbt dash, that is calculated stress due to the bending in the concrete, this stress we have to calculate. Then it can be calculated based on the basic design constant, grade of concrete, grade of steel, all these things, modular ratio, okay, lever arm constant. Then sigma cb c, it is nothing but permissible tensile stress due to the bending in the concrete, permissible tensile stress due to the bending in the, or bending compression in the concrete. Again it will and be taken from the table number 1, which is we have already discussed. So at the edges where the wall of the reservoir, or that nothing but reservoir means nothing but the water tank, are rigidly joined, horizontal reinforcement and the hinge bars should be provided to resist the horizontal bending moment generated, even if the walls arch designed to withstand the whole load as a vertical beam or a cantilever without lateral support. Okay, so this will actually we will see when we solve the problem over it, that will be more clear instead of this theoretical lines. So in case of the rectangular or the polygonal tank, the side walls act as two-way slab, whereby the walls with a continued as a restraint in the horizontal direction. This is we have discussed in the previous lecture that in rectangular or polygonal track, the side of the wall it acts as a two-way slab, and whereby the wall to be continued or restrained in the horizontal direction, that is nothing but a continuous slab fixed or hinged at the bottom or hinged or free at the top. The wall does act as a thin plate subjected to the triangular hydrostatic loading and with a boundary condition varying between the full restraint and the free edge. The analysis of the moment and the forces may be made on the basis of any recognized method. Different types of method, that is nothing but the approximate method, moment distribution method, Reisner's method, IS code method, all these are the method. However, the moment coefficient for the boundary condition of the wall panel or for some common cases are given in IS this 3370 part 4 for general guidance purpose. That, as I have said, that is also called as IS code method of the water tank design. Then this 6.4, that again refers to the wall of cylindrical tanks. So while designing wall of cylindrical tank, the different points that to be kept in mind or borne in the mind. Those are nothing but wall of the cylindrical tanks are either cast monolithically with the base or are set in the grooves and the keyways, that is movement joint, that we have to provide. So in either case, deformation of the wall under the influence of the liquid pressure is restricted unless the extent of the fixity of the base is established by the this anal, or that is the analysis. This should be analysis with due consideration to the dimensions of the base slab, the type of joint between the wall and the slab, and the type of soil supporting the base slab. It is advisable to assume wall to be fully fixed at the base. If such guidelines are not given, depending on the type of the tank, shape of the tank, water capacity, whatever the amount of liquid or the water to be stored, then in that case, the assume the wall to be fully fixed at the base. Then next is that is the coefficient of the tension, or that is ring tension, and the vertical moment for the different conditions of the wall. For some common cases are given in IS, again this 3370 part 4 for the general guidance. So again this coefficient for the ring tension, vertical movements, and all these things, that is called the IS code method of the analysis for the water tank. So all these coefficients are given in IS 3370 part 4, so that it will make so easier to design the tank by getting the value directly from these code tables. So next is clause number 8. So this clause number 8 we will see in our next lecture. Okay. Till that we will see this is in next lecture. Till that, thank you very much.